Hi, ladies and gentlemen. So I'm going to take you through two different examples with the same situation. I'm going to pick a different system for each example, kind of what we did yesterday in class with the other example of the ball falling through the air. So in this situation, we have a penguin who's on a sled, and this penguin is going to slide down the snowy hill. Notice that at point A, the penguin and the sled is not yet moving. They're just sitting at the top of the hill. B and C is when the penguin is actually moving down the hill on the sled. And then at point D, that's when the sled and the penguin have come to a stop. So notice, just like we did yesterday, that we first are going to kind of create our system. In this example, I am going to pick out everything that I possibly can to be a part of my system. So I'm going to include the penguin and the sled. I am going to include the hill or the ground that the penguin is sledding on, and I'm going to include the earth because this is happening on or near the earth. So you'll notice here that those things pop up in my system box up in the upper right-hand corner here. Now, remember, it's kind of up to you what you want to pick to be part of your system, but we all agreed yesterday that if we can include everything in our system, the easier things are going to be. So that's why I have chosen everything that I can think of. Is it happening on or near the earth? And then what objects are touching? So that's how I get the ground as well as the sled and penguin in this system. So now when we start thinking about our energy pie charts, so you'll notice that all of my circles appeared as well. I have put some guiding questions down below to kind of ask yourself to decide what types of energy get included. So the first question is the object moving? And the answer to that for snapshot A is no. So I know that I'm not going to include any kinetic energy in that first pie chart. Second question, does it have the potential to fall towards Earth? The answer for situation A is yes, that penguin has the potential to fall down the hill. So we're going to include some potential gravitational energy. The next thing, are two objects touching? The answer is yes. The sled and the snow on the ground are touching each other. If that's the case, you know that you can include thermal energy. However, the energy that occurs between snow and an object is so small that I'm going to actually ignore thermal energy in that situation. If you want to include it in this situation like this, that would be just fine as well. It would just be very small. And then the last question is a rubber band, spring, elastic, etc. type of material involved in the situation. And of course, the answer is no to that situation. So I know I'm not going to include any elastic energy. So the only answer that I answered yes to then is potential energy. I'm going to add that to my first pie chart then. Again, you could have added a little bit of ether, but if you want to ignore it because it's so minimal, that's okay as well in this situation. So snapshot B, the penguin is halfway down the hill. So yes, the object's moving. Yes, it can still fall further towards Earth. And so I know I need to include both kinetic and gravitational potential in that situation. Since the penguin is about halfway down the hill, I'm going to say that half of its overall mechanical energy is going to be dedicated to that potential gravitational energy. The other half will be dedicated towards kinetic. And we know that from snapshot A, since the penguin has picked up speed and has started moving, that's why we can now include that kinetic energy where it wasn't present in snapshot A. For situation C, it is going at its fastest speed. So it is going to be all kinetic energy in this situation. Again, we're going to ignore that E therm just because it's so small. But when that object has stopped, we know that all of the energy that it did have has now changed into thermal energy. So all the potential and kinetic energy that that sled had or was holding eventually all turns to E therm, which dissipates into the atmosphere. Okay, so those are your 4 pie charts for the first example. Now I'm going to use the same situation, but now I'm going to pick a different system to focus on. For the second time through, I'm going to use just the sled and penguin as my system. So I'm ignoring Earth and I'm ignoring the ground. And that's going to change what our pie charts look like. So with these questions, it's still the same 4 questions, but the answer to the last 3 is all going to be no. No, it doesn't have potential to fall towards Earth because Earth is not part of our system. Are two objects touching? No, because we're not including the ground anymore. So the sled and the ground are not touching anymore. And then still there is no elastic potential energy because there is no elastic material involved. So the only one that we're ever answering yes to is about kinetic energy. And we're still not even answering yes in every situation. So for snapshot A, when the penguin's not moving yet, we're just going to put an X in place of the pie chart. That penguin and sled is holding absolutely no energy within itself as a system at snapshot A. Snapshot B, the penguin is moving, so that's where we can include the kinetic energy. Snapshot C, it is still moving, so we're going to include kinetic energy because it is going a little bit faster at C as opposed to B. I made my circle a little bit larger. That's not a requirement. It's just a visual representation of the fact that kinetic energy is greater in C than it is in B. But because, again, we've isolated the sled and penguin as our only object in the system, we know that that energy that has been gained in the motion of the sled is actually coming from another system. For D, since the penguin is stopped again, we're going to just say that there is no pie chart that should be drawn for situation C, again, because there is no energy that the penguin and the sled itself is holding. So let's compare the two examples next to each other now. So we have this situation. We said that these were the answers for the two different systems given the exact same situation. Remember yesterday, ladies and gentlemen, we said that if we can identify everything in a system, like we did in example 1, it's so much easier to do our pie charts because we know we'll always have a pie chart as opposed to nothing. So I wanted to go over that again with you today to try and stress to you the importance of trying to identify all the objects involved in a system so we can avoid knowing when we should actually check off that there is no energy involved in the system. Please keep going back to this video if you need to rewatch it throughout today. Also, I want to remind you of the examples that we did yesterday on page 2 in our packet. So if you need to go back to that, feel free to go back to that page to kind of help you through your problems today. Good luck with the example problems. Make sure you're working together and collaborating and answering questions with one another. I'll see you Monday.